Yep. All right, questions before I make it look more difficult?
Why?
I'm just trying to prepare you for whatever my twisted mind comes up with.
Okay then, make it more difficult.
All right, let's see, we're gonna, I'm gonna erase this. At what time within the first cycle is the 6 kilogram mass at a position is equal to negative 3 meters? Now I could make it simple, and I said at what time will the mass be at a position of negative 6 meters? And that answer would be
0.
no.
Oh. Period.
At what time will it be at negative 6 meters?
Oh.
What was that?
I said negative.
No.
That doesn't exist.
Pardon?
That doesn't exist. You've pulled it 5, you've moved it 5, you're not getting -6.
That's the answer.
Physics? No.
Rip in the space-time continuum.
Magic.
Most it's gonna go is negative 5.
Because it can't have more energy than you gave it.
Yes. That probably would be the more sophisticated answer.
Okay.
All right, so at negative 3 meters, how would you go about this?
Is it the same using all of that?
Using all
All
of
those, like all the same numbers and stuff?
Yeah, I mean, all of this still applies.
Okay.
Which of this stuff would you recommend we start with?
Frequency?
Frequency is just gonna tell you how many cycles it makes every second.
I want to say. I want to say displacement, but I don't know. I think
This one right here?
Yeah. I was thinking. I don't think you can change the 5.
No, we don't want to.
Yeah, you
Because
don't.
then it's a different problem.
Yeah.
All right, however, let's go with your gut feeling on that one.
Okay.
Because I give you position, I'm asking for time, we just need an equation that has position and time in it.
Bada bing, bada boom, bing,
Boom.
bada bingo.
So if we use that first equation, then we get negative 3 is equal to 5 cosine of 0.9036t. And there's a stray mark there. Okay, now what? We're solving for time.
What is that word? First blank is no
Up here,
no all the way down. The first
cycle.
second.
Because if it's going back and forth forever, then if I just said at what time, then there's an infinite number of answers. I wanted to narrow that down.
Well, I just couldn't tell what word it was.
So solving for time, how do you do it? As with any algebra problem, how do you solve for an unknown?
Isolate it.
Yes. So what's the first thing we should do to isolate it?
5
Yeah.
3 by 5.
5 by 5. So I get negative 0.6 is equal to cosine of 0.9036t. And by the way, if you had put negative 6 here, like they with the verbal question, and divided by 5, you'd have negative 1.2. When you did the next step, your calculator will go, sorry, not doing it. Error or something like that.
Does the T go inside or doesn't inside the parentheses? Or
T is
doesn't it?
definitely inside the parentheses there.
Okay.
And you find the arc cosine.
Yeah, we're trying to get to T, so we have to get rid of all the outer layers, like trying to get to the core of the onion. You just peel away the layers. So So we get rid of the cosine next with the arc cosine, so I got an arc cosine of negative 0.6 is equal to 0.9036 t.
And just divide by 0.9036.
So time is gonna be equal to the arc cosine of negative 0.6 divided by 0.9036. And what answer do we get?
The right one.
Maybe.
We can help.
You actually, well, let's just see what your calculator gets.
Error domain. Well,
Actually, I should have done at what times, because there are 2 times.
awesome stuff.
What'd you get?
Error domain.
You had a cosine of negative 0.6.
Oh, I had negative 6.
Yeah, that, okay.
.4505. This one.
Second.
What'd you get for a cosine negative 0.6?
What cosine? So I got
I guess it would be, okay, I was thinking that you'd get a negative angle, but that's only if you're doing a sine. Alright, never mind. Okay, so there's 1 time right there. Think about this, the thing's oscillating back and forth from, and if that's 0, so somewhere over here. So if this is -5 here, we're asking about the times it passes by here. So it's gonna pass by it once, and then it's gonna pass by it a second time on the way back in the first cycle. I know that it's gonna take half the time, half of this to get to this end over here. So whatever number that was, there it is. So at this time, it's 3.47705 seconds. It's hitting this point at
2.4505.
2.4505 seconds. This was 0 seconds and 6.9541 seconds.
Would you just
sure.
you just take the difference and then add it to the 0? If you're trying to find the opposite time.
Subtract, wait,
So you're finding the difference between the 3.47705 and the 2.4505,
okay.
and then you move it to the other side. and
So,
subtract.
but then you're on the positive side. We're looking for a position of -3. You're almost there though.
Thus, we just take the difference. Call it a day.
Perhaps a bit too much in the wrong direction after that. But let's take the difference. What is the difference here?
.0265. 5. Very good.
All right. So so after it passes that point, it takes a little bit more than a second to get to the other end. And then how much time is it gonna take to get back to -3?
The same time.
Yes. So you would take that and add it to this.
Yeah.
I see, so we cannot code it again.
So 4 point something. 4.5036 seconds. Now, for those people who just love math.
Oh, question.
Yep.
If we were trying to find +3 and we had -3, like we just did, would it just be the same of adding the 0?
It should hit +3 at 1.02655 seconds. Yep. Cosine of 0.6, whatever angle you got right there. So this is pi over 2 radians, that's pi radians, that's 3 pi over 2 or negative pi over 2 radians, and 0 or 2 pi radians. When you get that answer in the calculator, it's going to give you something over here. The other solution would be an angle right there, where those two are the same. So it requires a little bit more trig knowledge, or at least angle knowledge.
Does that help you at all?
To find the other one more mathematically than what we did right there.
Okay.
Where you could find the a cosine of 0.6 and then add pi. Right. And it, similar process, if I said at what time is the speed 3 meters per second, or what time is the acceleration, whatever number I come up with. Same process.
This process taught me more trig than trig.
Better than
So,
picking it up in the streets.
Indeed, so.
so why did we have to do the difference from 2.4505 to 3.47705?
There's a symmetry there. The question was at what times, once I corrected the
Oh,
time
times.
there, at what times is it at
So you
negative
just
3?
wanted to.
Yeah.
Okay.
I mean, that's the bulk of the problem right there.
Yeah.
That is, so if you get that far, you should get more than half credit for the problem.
Yours.
All right, I was planning to stop talking about harmonic motion.
Why?
Are there any questions before we talk about particles in a box?
What kind of box?
Rectangular or solid? Empty, except for the particles.
Regarding the quiz, are we gonna have a quiz on this chapter?
Yeah.
No. So-
No more.
Did you want one?
Well,
No.
I wasn't planning to do the master set for this stuff either.
We're good.
But if I remember, I'll post the solutions so that you can still work through them.
through the master center?
Yeah.
Nice. And so the test that we're gonna have on Wednesday is gonna have what chapters again? Everything past what we did?
Energy, momentum, angular motion, harmonic motion, or vibrations, or whatever they call it. Anything that we cover from now on, if I ask it on the test, it would only be at the very general level.
Like, so thermodynamics is no go?
Well, what we're about to do, particles in a box, relates to thermodynamics.
Awesome sauce.
Were the homework questions, I don't know if you looked at them or remember what they are, for this week? For the, if we had a quiz, would they help us on the test on Wednesday for doing them?
Master set problem, probably,
Mentioned it.
if you have limited time.
And then that test, you said?
The Rube Goldberg test.
Yeah.
This is general covering all the material up to here.
So the Rube Goldberg test is the best, like, study for the test.
I just feel like it covered everything, and I just like the test.
One problem, right?
One problem, 15 parts.
So at this point in the course, I should be able to finish the Rube Goldberg test.
Answers are there. Should be a video link, because I've gone through the entire test in a class, filmed it. It's epic.
It's a conquest of the Rube Goldberg test.
A saga.
It's everything you dreamed would be in a physics video. It's there. Person standing in front of a board, talking,
Check.
that's pretty much it. No, writing on the board also. Sorry, no acetylene torsion, no duct tape, no cars flipping.
No explosions.
So except for those, everything you wanted in a physics video.
Indeed so.
Box. Particles in the box. All right, so what I am concerned with here is the force that is exerted on the sides, just to start out with. So first off, let's just say that there are n particles in the box. I know that if a particle hits the side here, let's assume perfectly elastic collision and that this side of the box does not move any noticeable amount. So the particle basically hits it at some speed, it's going to bounce back with the same speed. So in the very simplest case, I have a particle of some mass m going to the right at some speed v. It's going to hit the wall, and then afterwards, it's going to be coming back. At the same speed v. I believe there was a momentum Masterson question that dealt with some of that.
Yes.
What is the, let's just go ahead and say to the right is positive. What is the impulse exerted on the mass? I think I used I vector sign before.
Yeah.
We vector. What is impulse?
It's something to do with momentum.
That is correct.
Momentum times velocity.
No. That
Is it
would
close?
be basically half the kinetic energy. No, twice the kinetic energy.
Mass and velocity times momentum.
No, that would just be momentum squared. All right. We are primed for the test. Impulse. There are two formulas for it.
The change of potential, or, momentum.
Yeah, change of momentum. So that's equal to the change in momentum. What is the change in the momentum of the particle?
It just flips signs.
Say it again.
It just flips signs.
Okay, so therefore, what is the change in momentum?
0.
The difference, like if you go to 1 to -1, it's 2. Or is it 1? You go through 0.
Yeah, if you're going from 1 to -1, what's the change?
2.
1.
-2.
Negative 2.
Okay.
That signs matter. We're talking about vectors here. That's P final minus P initial, which is mass times, negative mass times V minus MV, negative 2 MV. All right, so that is the impulse that is exerted on the particle. What is the impulse exerted on the side of the box?
The impulse on the box, you said?
Yes.
It would just be the positive one?
Meaning,
Because, well, if it keeps all its momentum, doesn't lose any, is there any put on the box?
if we assume that there's a collision and momentum is conserved, if the change in momentum of the particle is negative 2 mv, what's the change in momentum of the side?
I wanna just say the positive.
It is. Whatever one loses, the other one gains. So the impulse on the side, so J wall, is equal to positive 2 MV. All right, so that is an incredibly simple case there. We can make it slightly more sophisticated in the fact that what are the odds that a particle is actually going perfectly horizontal towards the wall that we care about? What really matters is that x component. I mean, it's going down like this and it bounces like that. The change is still just in the x direction. So what I really care about is just the x component.
And the x component being what exactly?
Well, velocities would have
Direction.
set up x, y, z. It could be going in any particular direction. We just care about the component that is perpendicular to the wall.
I see.
Because that which is not perpendicular to the wall isn't going to change. So the change is only happening in the part that's perpendicular.
Okay.
All right, what is the other formula for momentum? Oh, sorry, try that one again. What's the other formula for impulse besides change of momentum?
1/2 mv squared.
No.
Force times the change in time.
Yes. So that should be equal to the force that the particle exerts times however much time of the interaction. I guess the force in the x direction. All right, so that's it for one particle. But if I've got just a single particle in the box, that's not really going to be much. But we do have pressure being exerted against it because we have a lot of particles banging against the side of the box. Just like right now. I mean, you are not exploding or going through the bins because you've got a lot of air pushing against you. And it's not all at once. It's not this pulsing sound. It's just one hits you and another one hits you, another one hits you. So we'll take some arbitrarily small amount of time there. And I want to figure out how many particles are going to hit the box in that amount of time.